No. Yeah, sure.
Okay, welcome back. Slight reorder as mentioned earlier on. This is Mike Appleby, Chief Executive Officer of Xybersafe.
Thank you. And thank you for giving me the opportunity to come and talk here at this event. I will be, in this session, I will be touching on the topic of the challenges the industry is faced with when integrating IT and OT networks. Now, I stress I will be touching on the subject because the subject is very massive and complex and actually would merit an entire convention by its own. So I'll not go into that. Quick background about Xybersafe. We're a Danish company founded in 2014 with a sole focus on developing systems that can secure data transport, both the confidentiality of the data as well as the integrity. So that's what we do. We weren't really looking or focusing on the oil and gas industry. We kind of stumbled across on it, our main focus was the finance sector initially, and later on the enterprise, and we worked quite a bit with the Danish power utility companies. But during our introduction to the market, we kind of stumbled into the offshore industry in Denmark, where we got pulled into a project. So what I'll do here, I'll go through the challenges as we see them, and then I'll spice it up with a bit of a use case at the end that we've actually deployed with a customer. So now, for decades now, the computer networks, i.e. the IT networks, and the OT networks, so the networks that control all the valves and the pumps and the SCADA systems, have been isolated, completely isolated from each other, and work separately. There's been no need to connect them. That is changing now quite rapidly, actually, largely due to what was talked about earlier, the innovation that's happening, and the need for the companies to actually address the digital market space that's evolving here, and the need for them to optimize their production, enable automation of the systems, and get better control of their offshore as well as in-country offshore deployments or regional offices. Obviously, these two networks, or these two types of networks are largely different. And this poses a problem, a big security issue, because they are very different in the objectives they solve today. IT has one objective, where OT has a completely different objective, and they're not really compatible. So when we start merging them, we are faced with a number of issues and problems that we need to address. So there's obviously the security factor of this. As we heard earlier, lots and lots of IoT or industrial IoT sensors and devices are now being deployed. I read somewhere that last year, over 1.3 million sensors that was machine addressable were deployed in the offshore industry alone, and that's just a growing number. That presents us with a problem, because that opens up an attack vector that we haven't been used to in the OT part of the organization. One of some of the challenges that we're faced with here are really, I would say, they're twofold. There's a technical challenge to this convergence of the network, as well as an organizational challenge. Now, from the technical perspective, the issue is that the IT networks and the people that run the IT networks, their environment is very different. They've been used to the joys of the internet and connecting stuff for many years, and they've run into all these issues, the security issues. So they have a fairly high skill level when it comes to connecting units, going into the cloud and all that stuff. Whereas from a technical perspective on the OT side, the people that run those networks are not really used to this. They don't have the skill sets. They don't understand the implications of actually connecting this. So from that point of view, there is an issue. From the organizational point of view, there's the culture. There's a very different culture in the two divisions. The IT part of the organization is typically very dynamic. They're used to working in a dynamic way, adding services as we go along, whereas the OT, they kind of like pull back doing that because they know the implication. Now, from the IT point of view, if something goes wrong, if we have a breach, hack attack or whatever, yes, there is an implication, there is a problem that will impact the company financially for sure. You may have to, as some heard about a Danish company, had to roll down a lot of backup and kind of restore the whole organization, getting it up to running, but it doesn't cost lives. Where we go to the OT side of the network, the issue is different because here, if we are breached, you will have a burning platform, actually. It can cost lives. And therefore, there is also reluctant inside the organization to work together, which is an increasing problem. We've been sitting in meetings with some major companies where we, as a vendor, actually kind of like act as a mediator between the two fractions, so to speak, in the company. And that is an issue. So these business silos, something that needs to be addressed. So looking at the capabilities that an organization needs to implement in order to make this transition to converge the networks and make them work together, there's a number of those. And obviously, one of the things that each organization needs to focus on is access control and credential management. Looking at it from an IT perspective, that's something that is done, but it's not. The focus is not as strict as on OT side. Because in the OT environment, they've been used to, it's a physical segregation of the networks. You have to be there physically to access something. Now, getting into connecting it into the IT infrastructure, even into the cloud, suddenly you are not physically there. You can be anywhere in the world accessing the system. So access control and credential management is a key thing and a topic of its own. Deep protocol inspection and intrusion detection is also something that needs to be addressed. Today it's addressed on the IT side, but not necessarily to the level that is needed for the OT side. So again here, there's a mismatch between the technology that needs to be implemented and how it needs to be handled. Incident response is also something that needs to be addressed in the organizations, as well as the assessment of what do we do. A lot of the companies that we've been engaged with, obviously they do have a security assessment plan and what do we do if something goes wrong. But it's very much different from what the IT department has to do, from what the OT department will have to do. And suddenly you have to merge the two and get a consensus of how do we work when these systems are interconnected. Vulnerability and patch management is a topic of its own. We've been sitting in many meetings discussing this. IT have a very tolerant approach to patch management. I mean, we in IT we patch at least monthly, if not daily sometimes. That's okay. Reboot the system and we run again. That doesn't really work in the the OT world. So there's definitely things to be addressed here in terms of patch management. We had a meeting with actually it was a manufacturer of trains, a German company, where you also start now to put in a lot of IoT devices. And as they said to us, one of our major issues is that the IT business, those people that create the IoT devices, don't really get what we are working with in terms of getting things approved for operation. I mean, they say, okay, you roll out all these sensors in your trains, and they get approved and run on the tracks. A month later, the vendor comes out with a patch and say, please roll this out. That's a no-go. That's why we have trains running today on the tracks that are have technology inside that are 20 years old. It's ruggedized, it's tested, so you cannot. So this is a big problem of rolling out the IoT and has to be addressed. So there's the personal aspect as well of the people, security awareness. A lot of the people in the IT side of the business as well as the OT don't have the same awareness of where the problems lie. And as you know, a lot of the problems that have happened recently has been due to malware, where people click. You know, you do spear phishing and you get people to click on a link and you're behind the firewall, you're already inside the network. So security awareness is a key component of getting this convergence to work. Obviously, network segmentation and secure information exchange is a key thing as well. And that's what I'm going to focus on now, because that is where CyberSafe comes into the picture. And I'm going to do this by talking about a use case that we had a while ago with an offshore company. I'm not allowed to mention the name. We were, but they got bought, and now we're working with the new owners to be allowed to say the name, so I won't do that. Just tell you that this company had a challenge. They were taking down a platform in the North Sea for various reasons, and that platform was kind of like the OT hub for a number of unmanned platforms. So during a normal operation, they would monitor these platforms that were unmanned. Now they're taking down this platform, and the issue is that they still needed to monitor the unmanned platform in this period before they could rebuild the new platform. And it posed an issue for them because, well, one way they could do it was, of course, to put down some subsea cables to each of these platforms. It's very expensive, hundreds of millions of dollars to do that, so that wouldn't work. They also needed, one of the requirements was they needed basically real live access to the systems out there 300 kilometers out in the North Sea. They couldn't have too much latency, delay on the signal, because they didn't have any people out there to turn the valve if something went wrong. So they needed to do that onshore. Now, shy of pulling out the cables and doing all that, they opted for a solution to use some of the operators that are out there in the North Sea and basically connect to their fiber infrastructure, backhauling the traffic into onshore. That posed them, and this was a solution that was proposed by the IT department. This is how we do it. This is how we do it in IT, no problem. We use these operators, we buy the service of them, we backhaul the traffic into an onshore network operation center. The problem here was the OT people were not too happy with that, because suddenly they had some consideration about this. They had to consider the traffic leaving the platform was traversing operators' network. So essentially, even though they bought a virtual link through an operator, they had no control of the traffic. The control was in the hands of the operator. It's not that they didn't trust the operator, but who's to blame if something goes, pardon my French, tits up? Well, at the end of the day, the OT guys would be blamed for burning platform. So they felt that they didn't have the control. There are a lot of things that can go wrong inside the operator. Human error is one of the most common things that happen. We've seen it before. So they felt they lacked control. So they needed a solution whereby they could have their cake and eat it. So they could use these slightly cheaper solution to backhaul the traffic, still maintaining a very high level of connectivity and low latency. So the way they decided to do it is, now I realize our presentations tend to get a little technical, so I try to, I hope you get the gist of it. So typically what happens here is that you ask the IT department to create a couple of virtual networks that are basically isolated from each other in a virtual sense. And they traverse the network, everybody's happy. Now here's the problem that the OT division was afraid of was that obviously you can have a bad guy inside an operator nobody knows about that suddenly, for some reason, hacks in to the OT part of it and starts fiddling around with old systems that haven't been patched for decades. Like some of these systems that they have out on the rig was 20-year plus running Windows XP, right? So they had to be isolated completely. One of the problems they envisaged was that, because this happened in the company before, actually, the company did in the IT department get a malware, and if something was wrong, the human error here, if somebody, did something wrong here, they were afraid that the malware could traverse the IT network and get into the OT network, which would wreak havoc on the platform. So this was not allowed to happen. So the solution that we proposed or worked with and developed together with them was actually, we added a security level for the OT that they were in full control of. So basically taking the control out of the IT department for the data and the information exchange and giving it back to the OT division. So the way that that's done is really by implementing a layer of encryption on top of the existing segmentation of the networks. Now, this way, the OT division could control all traffic exiting their network all the way through the operator's network, which were actually 3 different operators before it came onshore, and regain the control at the network operations center. So it gave them the confidentiality they needed, the integrity of the data. It protected them against man in the middle, as I said, somebody in here who tried to listen into the data. Actually, they were not so afraid of the listening into the data. They were more afraid of somebody messing around with the data, changing it. So the solution is now that they can basically, what they've done here, and it's quite impressive, they built an actual copy of the control center on the rigs and moved it onshore and basically extended, like it's almost like pulling a cable like this, all obviously not with the cost of actually pulling a fiber cable this way. So that kind of concluded their ability to do what we call crypto segmentation and actually control the data flow. Quickly, the problem was then, and I'm going to wrap up here, I see my time is running. Quickly then, the next problem was, now we got all these information and we got them on a closed network. Now we need to move it, because we want some people, we were talking about big data, we need all that information to be utilized in the IT business. So typically what they do is we set up a firewall with a lot of policies, making sure that traffic can flow this way and that way and stuff like that. Again, the OT division was not too happy because they're not expert in firewalls. So it was outsourced to a third party, and again, we're putting our trust in that they know what they're doing. And as they say there, the more complex a system is, there's a bigger chance that something's going to go wrong. So they wanted to eliminate the human error aspect of it. And firewalls, although they work and they're very good and you should have them, they're not perfect in every aspect of the solution. So we proposed a different approach to this, a more military kind of approach, where we use what is known in the business as an information exchange gateway, which is basically a piece of hardware that only allows traffic to flow in one direction. And it's a physical one. It's not a logical one where you have some software that could have a bug. This is actually physically only allowing traffic to flow in one direction. And then you put in some proxies and you get people, some managers that actually have access to that data and can view that data and determine whether or not that data is allowed to traverse between the networks. So this actually achieved the objective of both the IT and the business as a whole, wanting to access a lot of data from the platforms, using it to compete in this digital market space, whilst also securing the OT guys that they still had full control. So that pretty much concludes what I wanted to talk to you about today. And I know it's a very, very vast topic. And and this is just scratch the surface of it. Thank you. Oh, yeah.
Thanks very much.
Yeah, I was online.
I should point out that from the beginning of that speech, we're now live streaming across our website.
Oh, thank you.
and through the house.
That was my hair.
So I think people will remember you for OT, IT, and your explanation TU. So next we have John Staff from Oceaneering. Please, John, if you want to come up and Ben will mic you up. Just pop that in your pocket.
Okay.
Okay, I don't know if that, thank you. Is that working? Everybody hear me okay?
Mm-hmm.
Right, okay, well, we'll, is it just that button there, yeah? Okay, well, apologies first of all. You were supposed to be getting our technology expert, Jim McNeil. Jim's been with our company for a long, long time, probably 40 years in the industry, and it's actually Jim that put together this presentation. Unfortunately, Jim's got stuck out in Baku, so last night I was drafted in. I guess you've got the better looking and younger one, but that's my opinion anyway. So yeah, my name's John Staff. I'm the Senior Operations Manager for Oceaneering. And we're here today to tell you about our Taxi digital radiography system. Taxi is a bit of a bit of a pun on what the actual device does, but it's a trip avoidance X-ray inspection system. That's what it actually stands for. So we'll go into how that works. But the problem is at the moment in the North Sea or UK continental shelf, typically there's half of the shutdowns, unplanned shutdowns, are caused by trips with plant. And unfortunately, to say, companies like ourselves that perform radiographic duties out in the North Sea are often typically the culprits. We will go along to carry out radiography, and our radiographic sources that we utilise for doing the radiography can trip the plant, and we'll explain that to you as to why that actually happens. But obviously, the problem for us is that we're not Mr. Popular when we go offshore, and we're trying to carry out radiography to investigate the integrity of the plant. So we've come up with Jim has actually come up with a solution to this with a piece of kit that we want to introduce you today. So, as it says there, unscheduled production upsets or trips of pressure plants cause loss of immediate revenue, obviously to the operators, and obviously there's an increase in risk to health and safety of the personnel. And as I've just explained, these can be false alarms caused by radiographic work. So what actually happens is that the nucleonics that are used to measure the levels of the fluids in the various different pieces of plant offshore can be tripped or conned by our radiography output. So there's a typical vessel, as you can see, with its own nucleonic source there. And then you've actually got the radiation detector, and it's a very simple process. Basically, it enables the operators to see what sort of fluid levels are actually in the vessels at the time. So now we're nothing to do with this. This is part of the operation, but this is what we interfere with when we go out and carry out our radiographic duties. So basically what happens is that our radiography causes nucleonic detectors to trip production, resulting in the unplanned shutdowns, which you mentioned earlier. And last sort of estimates was that can cause up to, $1 million a day in lost production. That's an estimate. We then have issues with plant startup. Because it's an unplanned trip, it can often be something like 48 hours before the operators are able to get the plant back up and running again. So you can imagine the consequences there. So we're not always, as I said, Mr. Popular when we go out. So the alternative is to isolate and run the plant temporarily blind, which is obviously not the best solution, but that's what we've been doing to press. That's what we've had to do. In some cases, we just don't get access to the plant to be able to carry out the necessary inspections. And of course, the inspections are necessary because it's a bit of a two evil situation, because if we don't carry out the inspections, then the operators are not able to understand what the integrity of the plant is looking like, and that's obviously key to continued operation. So we've actually got a little video here which we can show you. Hopefully. I've got some sound anyway. So this is the typical radiographic work that we're carrying out on a piece of pipe to inspect the integrity of it.
Oceaneering is redesigning asset integrity, seeking new ways to add value for our customers. We have solved the age-old production problem of performing radiography inspections on installations with nucleonic level control instrumentation. Using our taxi solution, we can carry out in-service radiography inspections on safety-critical corroded pressure piping without having to defer work scopes. Using this unique solution, operators can assess equipment in the vicinity of nucleonics and avoid unplanned process shutdowns known as trips. Our fully tested equipment precisely follows IRR 2017 legislation and will reliably detect and size corrosion in facilities pressure piping, especially when insulated. We help customers remain in safe control of the production process, avoiding plant isolation and reducing risks from loss of primary containment. Our taxi solution can be used for radiography of pressure piping in any industry using nucleonic instrumentation for process control, without affecting plant and equipment.
Okay, so that's kind of a bit of an oversight or an overview of what it's all about. So going back to the slideshow, this is obviously what a typical radiography operator will be doing. He's going to expose the radiographic source, and unfortunately, in this case, it's actually next to a vessel which has its own nucleonic sources. And what happens here is we fool the radiation detector or the nucleonic here into thinking that they've had a vessel evacuation. And of course, on a lot of new plant, that immediately trips the plant down and we have a shutdown. And obviously operators don't want that. So what we've had to do in the past, we've had to actually switch these things off. Well, the operators have switched them off, so they're then working blind while we carry out our radiography. And that's obviously not the best scenario. So typically a nucleonic, as we said, is located on vessels like this. It's obviously used to measure where the levels are, the liquid levels are. Typical view, if you like. Again, that's the actual, these are actually the measuring devices. And these are the photographs of the actual devices on a platform. They're actually sometimes quite difficult to see, but these are the ones that are causing the problems. These are the switches. So here's your level indicator here. If that then sends a message to the switch, it switches it out, it switches the plant down if it thinks it's, it's the vessel's been evacuated. So what we've come up with is actually a device, or I'll say Jim's come up with, is a device that has been used actually in America for a number of years. It's been used for detecting armaments, drugs, things like that. It's used by the various different forces over there. A handheld device, would you believe? And they'll check lorry tyres and backs of cars, things like that. You know, where they need to be able to get access into the back of or into an enclosed space, and they'll carry out an X-ray with this system. We saw potential in this, and we thought, can we use this in our industry? And the answer to that was yes. So what we've had to do is actually develop this for use in the UK, because legislation in the UK is a lot stricter with regards radioactive producing devices, be it an isotope or an X-ray machine. So we've had to develop safety systems, an operator indicator unit, which is this device here. We've had to add in remote control switches, collimator which controls the beam, and a very special monitor. Unfortunately, the monitor is actually the key part to all this as to why the technology works and doesn't trip the nucleonics. A typical monitor that we use actually uses a Geiger Muller tube, something I'm sure you've all heard of, and that actually measures the amount of radiation at a given time. But because this doesn't work in a conventional way, it pulses. Conventional monitors don't actually pick that radiation up, but this one does. This is an accumulative or an average dose rate over a period of time, so it actually measures that radiation. So once we've got the actual equipment in place, the actual X-ray unit, we then have to use something to detect it, to actually turn that radiation into an image that we can use to assess whether the pipe or the asset that we're looking at is actually in good or bad condition, as either way. This is called a DXR system. It's a real-time radiography unit, and we use this in conjunction with that. So we're able to actually use this out on the platform itself, and we can see real time whether we've got the image or not. And this actually needs very, very little radiation to be able to give an image, which is another reason why we use this with the X-ray, with the pulsed X-ray system, because the pulsed X-ray system has a very, very small amount of radiation compared with a conventional X-ray unit. We can also use what we call a CR plate, which is a phosphor plate. To get into more difficult areas, the phosphor plate can be put into a flexible screen, and we can get into all sorts of areas with that as well. So these are what produce the image. The X-ray system, the pulsed radiography system, or the taxi system, these are parts of that system as its entirety. Okay, so the biggest issue is convincing the facility that radiography is now safe to use and won't trip their plant. For years and years, we've been the bad boys. You know, they could actually tell us where we were on the platform just by us walking around with an isotope. They would be able to say, right, the guys are just going over to the gas plant. We can actually see by the monitors in the control room where we were, and that was before we'd actually exposed the source. So the science behind it is that there are a millionth of a second pulsed X-rays from our device, and what happens usually is that when we expose a source, the Geiger-Muller tube, or the scintillator, the nucleonic as we call it, is saturated. So we've got this device on a vessel that normally tells the operator that what his level is in there, how much fluid he's got in there, how much product, and then all of a sudden we come along, we expose the source, and that Geiger-Muller tube or the scintillator is actually blind. It's actually saturated. So what we've done, we've got together with the actual manufacturers of the nucleonics, two main ones in the UK, and what we've done is we've worked with them very, very closely, and we've actually been down to their manufacturing facilities and tested out our product against their nucleonic devices. And part of the process of the taxi process is that we speak to these guys. We actually get the serial numbers of the nucleonic devices from the operators, and we send them to the manufacturers, and they come back and tell us what a certain amount of data of basically the calibration data for that particular nucleonic. So for instance, if we look at this top one, we've got a low level reading of 121, and we've got a high level reading of 23. So when I say low and high, 23 is what we would expect a reading of when the vessel is full, and 121 is what we'd expect when it's empty. So we've got a span of 98. Now, when we did the tests on their products, our system, there was a deviation when we exposed our X-ray system. There was a deviation of 30%, which sounds quite a lot, but it isn't in real terms. As you can see, we've got various different deviations: 14, 7, 16, 39, 12. Quite a large one there at 59. But all these are known factors. These are all known deviations. So this is us down at Tracerco, one of the manufacturers. They manufacture GM tubes, and this is their laboratory where they do all the testing. You can see our system here set up actually in front of their nucleonic. So we're firing our device directly at their nucleonic. So those figures that I've just shown you, these are worst case scenarios. That's where our device is actually in front of their nucleonic. That doesn't happen in reality. So we've actually worked with these guys, and we got that information. That's part of the package that we're able to provide. So we had 2 days of testing on their level gauges and switches, and we were able to establish what the percentage fluid level deviations were. So that means that when we go out to a platform, we can tell the operators, look, if you see a 10% deviation in your nucleonic device, don't worry about it, that's just us. If you see a 20%, then you've probably got an issue going on. So they are known factors, and that's part of it. We also worked with a company called Endress and Hauser, who actually make scintillators. And scintillators are typically used in really, really sensitive areas, gas plants, things like that. And they're very, very sensitive pieces of kit. And again, firing our camera directly at this is actually one of the measuring units, one of the scintillators. Firing it directly at that, it was unable to pick it up. This gauge here, you'll not see it, but it actually says 6 millisieverts per second. That's the actual measurement of the amount of radiation that was fired at that, and that would normally fry that. To put it bluntly, it would just shut it down completely. That was the amount of radiation that this was fired at, but he didn't detect it. So what we've found here is that we're able to carry out radiography in a nutshell and not actually affect any of these devices, which is great news.
Can I give you your 1 minute warning?
Yes, you can, yeah. So what we've got here is an illustration of what happens with normal radiography, where the nucleonic is active. We expose our source, and then the nucleonic is dead. It's not able to recover for sometimes up to 2 to 4 hours. The pulse radiography, this is the same scenario, but because we're firing very, very quick pulses, something like it says here 15, 25 nanosecond wide pulses in 1 second. So consequently, the nucleonics aren't able to detect the actual pulse of radiation. They do to a very, very small amount, but they're able to recover just as quickly. So this is a typical setup on a platform where we've got the barriers, the source here, and all these are the nucleonics. And at no point, as you can see, they were very, very close to the source, but at no point did any of those trigger. This is actually a graphic image from one of the process units, and this is a period of, as you can see, 9:30 in the morning to 11:40 in the morning, and this is just standard fluctuations in the vessel. During that period, we carried out numerous shots, radiographic shots and images on that particular vessel. Okay, so I've kind of covered that anyway, and as this gentleman's pushing me for time, I better not go into... No, you're all right. Not a problem at all. So these are some of the sort of images that we're able to produce. So you can actually see things like the thinness of the wall here, 0.7 millimeters. It would have been typically 3 to 4 millimeters thick, and you've got the erosion or corrosion taking place in that pipe. This one, we've got some erosion here in the actual, or corrosion, should I say, actually in the root of the weld. Again, you can actually see the scale on the outside of the pipe, but you can also see the internal diameter of the pipe there. It's down to 1.2 millimeters as opposed to 4.8. And we can also use it for tubing, for inspecting swage locks, things like that, if they've not been manufactured or set up correctly. So we've ended up here where we've got some gaps in the tubes. This is actually this is nuclear waste in actual fact, but we've added this one in just to show you the clarity of what we can see using the X-ray device. The sort of wave effect that's around it is actually polythene bags. So you can actually see this is a can, inside a plastic bag, inside another can. But the little beads that you can see there are all the pellets of depleted uranium. So we've been using this device for that. Okay, last one. Bit of a can you spot the difference type slide for you. This is a typical flange bend on a production unit, and we were sent in to find out what the thickness was of the pipework. But we actually realised what the problem. They actually thought they got a leak, or they had, but there was a reason for that. Okay, and that's us. Thank you.
Thanks very much, John. Much appreciated, and especially as you were parachuted in at last minute, you did it especially well there.
Thank you.
So next up we have Thornton from Robot. I'll let you get straight to it. Thank you. Once you get the microphone up.
Sure. Thank you.
Yeah.
Okay. Thanks. Well, thank you, John. I've got a similar story to him. I'm talking today generally about innovation and digitalisation in subsea robotics. I say similar story, I mean a similar story as to why I'm presenting here. You think this is a perfect subject for our head of technology who came up with the presentation, but he doesn't have such a good excuse. He's away in Disney this week. So, anyway. But and it's a very general commentary on what's happening, what the trends are, what we see. So there could be some references in here to other companies, other people, and if there's companies represented in the room here, I hope you don't mind us using your imagery. It's free publicity and it's a positive reference. If you allow me the liberty of 2 slides only, it's the only 2 slides on RovOp, on the company, just to set the scene of who we are. We call ourselves an ROV company, but actually we're focused on subsea robotics and its technology advancement and applications. So within the company, there's quite a few people with years of experience in this area, and we're independent, so we've got the flexibility to innovate, and I guess the commercial models as well gives us a bit of freedom. We're running about 50 ROVs at the moment, but as I said just earlier there, we're called an ROV company, but actually our internal vision now is to, just recently we've been talking about leading the world in subsea robotics. That's what we want to be doing in future. I'll explain a little bit why we've changed direction like that. Excuse my crib notes a second as well. This is a quote that we quite like, just to set the scene, a bit of thought-provoking today. It's from a George Westerman who wrote it for a MIT management review. Technology doesn't provide value to a business, but rather technology's value comes from doing business differently because technology makes it possible. I think you touched on it, Mike, a little bit, and others, and Fredrik. It's not focusing, it's more about transforming the business, not focusing exactly on what technology can do. I think it's very relevant in this world of subsea robotics, because you'll see many iterations of designs of various new technologies, but actually you have to take a step back and say, how do we actually transform the business and the industry? And also, there's another point this guy made, was not to maybe move too fast too soon. If you look at all these, I'll show some great imagery of some concepts, and it can make current designs and what's possible now seem a bit mundane, but actually that might be something that unlocks innovation, incremental steps. That's kind of the theme of this discussion. Again, just setting the scene, this is kind of unrelated to the oil and gas industry, but I think it's quite an interesting snapshot of largest global companies by market cap from 2008 to 2018. It's quite a stark illustration of how things have changed. This has probably changed, if you can see it okay, this has probably changed more in the last 10 years than maybe the preceding 50. So the main message here is that companies have to be comfortable being uncomfortable, I guess. And if you don't perceive shifts in the way things are changing, then you're going to die. Here are some good examples of exactly that. I don't know if anyone remembers Blockbuster here, not so long ago, but that's all about the vision they had that was perhaps not forward-thinking. A great business, but not forward-thinking in the vision. Okay, so just to set the scene a little bit, obviously we have all the types of fast-moving stuff that's happening at the moment that we've talked about. So what does it mean for our industry, I guess? When I talk about subsea robotics here, can it really do these things? Can it enable new field developments? Can it improve production efficiency and reduce O&M costs? And I guess the latter one is very important here in the North Sea basin. So some trends in subsea robotics, again, reiterate, this is a commentary of what's happening in the market, hence the first vision for the future. So here's a very grand vision. Just to quickly explain this if anyone's not so familiar with it, but here we have a range of vehicles that are completely autonomous, untethered to the surface, doing their own work. There might be lots of different designs, coping with different tasks and types of work, but they can all come back to an homogeneous docking station where they can charge. They don't have to come back up to the surface. They can download and upload large chunks of data. So it's a grand vision, excellent concept, but then how do we get to that point? Because it's not an immediate jump. So we're looking at this and what's the main steps, the trends that are happening at the moment. Just like our onshore networks, onshore power grids, there's a more push for electrification, same thing with subsea vehicles. Then you're moving into things like remote operations where you can take less people offshore, have people back on the beach. Then we move into the world of automation, autonomy, which again, we'll look at this in a little bit later, but it starts to change the market landscape, particularly for the vessel market, where you don't have so much need for expensive subsea support vessels. And behind all that, there has to be new operating and commercial models. The industry would have to change. So we'll go through some of very briefly, some of the key points. One of them's data, and we talked again, I think, earlier about bringing more of this onshore onto the beach. So you need data coverage. Thankfully, we're very used to 4G and 5G coming in our mobile phones. So we've got that already. The data transferability is there already. UK, Norway, some parts of Gulf of Mexico, coming soon the Dutch sector and deeper water areas. So the benefits of 4G is it's low latency and high bandwidth, which is ideal if you're trying to control a subsea robot effectively. And the world of remote operations. Now, a few companies are doing this already, and I've implemented this quite successfully in demonstrations, actually live missions. Here, when I say remote operations, I mean you're taking maybe 1 or 2 people back from an ROV crew or an AV crew, and they can be in the comfort of an office where you have instant access to them. The clients, customers come and speak to you and see the mission happening real time. If you need subject matter experts, it's much easier for them to be there. So there's a lot of clear benefits to it, not just the cost saving offshore, bed space and sustenance and transport to and from platforms and vessels, but also the health and safety, the safety aspect of it, of course, which reduces the risk to the customer. And I mentioned here, again, this would be Lee's subject definitely, but you can also then, it brings open into pulling into things like digital twins. I think we'll hear about that quite soon as well, a little more detail. But it's perfectly compatible with that type of, and quite suited to that type of technology. And then the further step from there is bringing the actual pilots of these ROVs onshore. And again, this has been done. It's been demonstrated by a few companies, and it's getting uptake. Particularly, Norway is actually leading this so far. But it's again, it's the same thing. The low latency and the high bandwidth allows you just to simply. You don't need to be sitting on a platform. You don't need to be sitting on the vessel. You can be in the office flying the ROV remotely. AUVs and fast ROVs have actually been around for quite a long time. So again, autonomous underwater vehicle, just in case anyone's not totally familiar, the ROV has an umbilical to a surface vessel platform. AUV is completely autonomous. It doesn't need any attachment, if you like, to a surface vessel. So they've been around for a while, and they're particularly suitable for covering large areas at any one time, doing seabed mapping, survey works. But they still need some sort of check back with a surface vessel. They still need some sort of surface vessel support, checking the position timing now and then. But what they do is it reduces vessel time. So they're not taking away the vessel, but they're taking away, the vessel is spending less time on site and therefore less cost. But data quality is the key as well, and you need people processing that on shore. And then moving on to, so they're very good at flying in straight lines and covering large areas, but then if you need to do some intervention, there's also designs out there for hybrid. Well, we've got hybrid cars, so hybrid underwater vehicles. By that I mean it can be an ROV where it's sort of piloted, or it can just be doing its own thing. So a vehicle like this might fly to the work site itself, and then you need to do some more detailed intervention, and the operator then takes over. He may be in the beach, in the office, takes over to do that work. So all of these are they're all changing the landscape. Not alone, and the technologies out there alone. This is probably the main point. Alone, they're not. They maybe don't radically revolutionise things, but it's always incremental steps to get to these points. And these incremental steps are important. But if we go back to the idea of platform resident vehicle, can you imagine in the future platforms offshore that have their own vehicles there? They're not manned. They could be deployed subsurface. So you first of all, they're always there, of course. So you have them on hand whenever you need them. And you don't have the problem of launch and recovery, which is often a limitation in high sea states and bad conditions. So in future, that would be a great vision. You've got all these platforms that need this regular maintenance, but it's costly to send ships out and people out all the time. Once this industry takes off, that can prove clear benefits. This is an interesting area as well for autonomous surface vessels. It looks like I was down at Ocean Business, a technology conference, just the last few days, and it looked like being back at the park in the 1980s, where there are all the remote control boats flying around the harbour. So there's a lot of this now. They're a bit more sophisticated than that, of course, and taking it to another level, you could have autonomous surface vessel mapping, doing survey work, launching a vehicle, a subsea robot, into the water, which is then controlled from the beach. In future, you might have a fully autonomous vessel and a fully autonomous vehicle. So it's quite there's a lot of developments, as I mentioned earlier. A lot of things happening at the moment where there's bound to be consolidation in the future because not every technology survives, and that's probably where ROVOP is. We're looking at where we are on the line. And we have that sort of scale still that we can then pick out the best technologies. And that again, it was mentioned earlier, we're the same. We're willing to talk to people now about these types of technologies. It's always good to also have in any market some disruptors and new entrants who shake things up a little bit. So there's various concepts around from snake-like, well, it's eel actually, but snake-shaped robots. You can imagine difficulties some of you might face in remote in intervention areas, flow lines and subsea structures that are very hard to access. So again, an autonomous robot that can get into those areas. Some other ones that literally transform their shape, much like planes, certain plane designs do, to optimize their operations for whatever they're doing. We talked about the AUVs being good for free flowing, for long line running, but not so good for hovering. If you can change the shape of the vehicle, then you can do both. And other entrants, we've got Kawasaki mentioned there, but it's just one example of another industry player coming from outside with a different perspective, background in factory robotics. And it's always good to, and that's what this industry really needs is to, I think it's been talked about for many years, to really engage with other industries who quite often are doing this type of thing better. And finally, it's just we'll recap again. We showed the image of the resident vehicles. They're always down there. It's a great vision for the future, but how do we get there? And it's these incremental steps. Some of them are small gains, some of them very disruptive. But it's the way the industry is heading, and again we are sort of stepping back from that point, viewing it all, seeing what's possible and what partners we can possibly work with. That's me. Well on time. Thanks. Well, yeah.
Appreciate it.
Wasn't quite as last minute as John, but
I'm sure your friend will be enjoying himself on a roller coaster.
yes, I'm sure.
Paul shows. So next up, I think Paul just referred to it there, we're going to talk a little bit about the digital twin enabling technology. We've got Thornton Brewer from FutureOn, one of our sponsors here today. If I could ask you to do the necessary with the mic.
Thank you. Is that okay? Yeah. Okay, perfect. Yeah, do you have my slides loaded already, or do you need the... Oh, yeah. I'll just put it in here.
Yeah, that's fine.
Is that okay?
Just click next.
Okay. Which way, left or right? Okay. All right. Is someone keeping track of my time, or do you want me to?
I'll give you...
Okay,
don't worry.
perfect. Hi, everyone. My name is Thornton. I am a representative of FutureOn. We're a Norwegian technology firm, and we're working in the oil and gas space to kind of introduce digitalization strategies for oil and gas, looking at mostly greenfield or pre-feed field development. But I'm here today to kind of talk about the digital twin. I know it's a buzzword, and I'm sure a lot of people get tired of hearing that. No one has a very good explanation for what the digital twin is. And that's really because it encompasses a wide variety of topics. It encompasses topics that go beyond oil and gas into more technology perspective and things that maybe aren't right now very useful for oil and gas's purposes. But the digital twin sits within this kind of trend and these buzzwords that you can associate with IoT sensors, process automation, real-time data streaming, as well as application program interfaces. So is the digital twin really just a connection between other programs that are represented in one single unified way, et cetera? And so really what we've found is that the digital twin that we can do to enable the digital twin through our revolutionary technology is really to support that integration. So how can we properly represent the data that's being created by these IoT sensors? How can we properly represent the data that's being created and that's stored in siloed information systems for engineering, et cetera? So Forrester Research estimates that a lot of data goes unused in the offshore environment. We had a client of ours do an internal review of their systems. I can't say the name, but it's a large Norwegian operator. And they found that over 80% of the time that their engineers were spending at work was spent trying to find the information that they needed to use for operations, and then to actually use that information only took about 20% of the time that they were at work. So what we want to do is help to revolutionize that process, to make data more transparent and to make it more accessible, to help the workflow itself from pre-feed field development all the way through to operations be a much more seamless transition between operator and service provider or client that provides the transparency, which reduces the inefficiencies in the market, which allows engineers to do more of what they're really good at, which is not looking for data, but actually using that data to make manageable and concrete insights that help to revolutionize the business process and provide marginal improvements. So if you think about the digital twin as really a data representation of a subsea asset or any kind of asset, what we're providing is a platform that enables that. So we're through our platform technology, which is 100% cloud-based, though it can be supported on-prem or in some kind of configuration. What we're really doing is providing clients with a platform where the real field asset data can then be represented in a digital environment where you can bring in modeling data, you can bring in modeling systems to create options to see if there's optimization within the field that's possible, if you can create new routes, or if you can increase production or decrease production and actually improve your operations. So 3 things that we see the digital twin doing and how we're helping to enable that is reducing costs. So the pre-feed field design process can actually be reduced on average through the responses that we've gotten from our clients and the internal reviews that we've done, by anywhere between 30 to 60%. So you're taking project development times in the greenfield from 6 months to a year down to 3 to 4 weeks, because what you're doing is you're providing a group of engineers with the same data in a collaborative environment, and then you're also providing those managers and the people who are making those difficult choices as far as where the investment dollars go. You're giving them accurate real-time data that's also been widely seen and circulated throughout their internal management system. We're also reducing risk, because if you have a single source of the truth, you know that the decisions that you're making are accurate, or they're based on the best real-time data that you have. And reducing risk, if you work for an operator or you are a service provider who works closely with an operator, or you've been in the oil and gas industry for longer than me, which is only about a few minutes, you understand the importance of risk and leveraging that risk, managing that risk, reducing your risk. Because that's really, that comes in many phases, but that ultimately boils down to human safety, and it also boils down to making sure that equipment costs are kept low, because you don't want to install a damaged piece of equipment. You don't want to make interventions in the field that are unnecessary. It also increases efficiency. So by leveraging the real-world data that you have in a digital environment, you're able to see more unique connections or optimize solutions that weren't otherwise visible to an engineer who's incredibly intelligent but doesn't have the eye for seeing these connections in a spreadsheet that has 1,000 cells, or is able to manage both their day-to-day tasks and these other kind of external optimization opportunities. So now you're able to increase efficiency, because you're able to leverage the skills and the abilities of your own internal employees, as well as be able to share that data in a restricted manner with other service providers who can provide greater insight. So what we really see is a simultaneous development. So instead of retroactively developing a digital representation of your field once you've completed the installation or once you're already within operations, we see this new trend within the market emerging that really supports this idea. It's more efficient to create the real field simultaneously to a digital representation. So from day one, when you're beginning that first concept, put it into a digital environment so that you're able to make modifications, and you're also able to digitally track the changes that are made in the real field environment along with this digital field. And what does that do? Well, that provides you with a lot of opportunity for retroactive enhancements. So as you begin to have a database or a data silo of your field developments, you're then able to put that into AI technology to optimize new solutions and to create basically an improvement feedback loop, where you're always learning from your previous operations to improve your next operation cycle in kind of a spiraling upward trend, because that then creates more efficiencies and improves the deliveries that you can provide to your clients, or if you're an operator, that your service providers can provide to you, and then through to your bottom line. So what we have through our platform, which is called Field App, we have multiple layers of data that we're able to integrate. So this isn't just a one-stop shop kind of, you can integrate your bathymetry data and then kind of do a dumb rendering of the field. We can integrate a lot of very specific engineering data within one unified platform that provides a myriad of interested parties with a great deal of data at their fingertips. What you're seeing here is a 3D rendering of the field. We can show the field in both 2D and 3D. What you see here is the mapped reservoir information, the well pathway data, and then you see the bathymetry data on the sea floor, as well as pipeline lay and manifold and wellhead installation. You also have the ocean was turned off for better visibility, but you also see vessels floating on the surface, and you can also with vessel placement as well as topside asset placement, FPSOs, et cetera, you can optimize their placement based upon the design that you do in the subsea environment as well as the installation schedule. So this is a 2D example of kind of what the product looks like. Through Field App, we're able to include metadata. So as I was talking earlier about the importance of getting data out of silos, it's really important that each of those assets that we brought into the field wasn't just a dumb representation of an asset that exists in a real world environment, but that it's also fully representative of that piece of equipment. So what you have here are numerous types of metadata which you can associate with your asset. And for idiots like me, metadata is just data that describes data. So I had to learn that, and it's actually, it's crucial to the business operations because a lot of different, it's crucial that it's optimizable for business operations because a lot of different clients that we work with have totally different systems to manage their data, have totally different ways that they name their data, even though they are maybe the same kind of data. So it's really important that through our API, you can rename all of this, and it's completely customizable so that it fits the solution that you can provide to your client. So I just want to show a brief video. This is a quick little teaser of what we were able to do with a client of ours, McDermott. They're using our subsea system to leverage their Gemini XD program for their subsea digital efforts in the marine operations perspective. Do I press play or next or?
Last year, we focused on transforming the subsea industry by visualizing field planning through digitalization. Now, in collaboration with FutureOn, McDermott is using Field Twin to revolutionize workflows and enable our clients to develop their subsea digital twin from planning through engineering to first oil and beyond. Field Twin is a cloud-based platform that visualizes complex subsea knowledge for faster early concept development and sign-off. By uploading years of subsea engineering and installation data to this powerful platform, McDermott can develop and install subsea fields significantly faster while lowering overall risk. Merging previously separated data silos into one collaborative platform provides our clients with an assimilated and real-time view of their projects. Our new digital platform offers a visual, user-friendly interface with the resources needed to build, estimate, validate, and share field developments in a secure, globally accessible cloud environment. Project owners can choose to share information digitally while retaining control. Key project stakeholders are kept up to speed, enabling faster decisions and efficient collaboration. Integration of functions from other applications enables engineering processes to make use of the digital basis of design and retrieve live data from costing databases through an integrated API to get quick project cost estimates. Combining McDermott's historical data and expertise with the power of Field Twin enables our team to simulate and validate marine operations, making them more efficient and safer with minimal downtime. Our engineers are empowered by Field Twin to focus on what they do best, improving logistics and optimizing design solutions. This cloud-based platform gives McDermott and our clients continuous access to real-time projects, ensuring secure and accurate data across all phases. Our investment in digital technology is revolutionizing our business model and empowering engineers to deliver transformational change to our clients. Together, McDermott and FutureOn are forging the industry standards of tomorrow.
Okay, perfect. So that was a bit of a teaser of what we're able to accomplish through the integration with some of our clients. So basically, as a final iteration of what I've talked about today, we really feel like digital transformation, especially in enabling the digital twin, and whatever that means to your client, whether it's actual 3D representation of their assets, or they just need a complete data integration platform that provides them with a solution to integrate their different engineering programs, or whether it's something that helps them calculate early estimations for costs, marine operations and installation, et cetera. What we're able to do is create basically a streamlined approach that ultimately affects the bottom line. And so we're looking at these integrations that, through collaboration and quality communication and open access to data, that leads to substantial cost savings and improved operability, which oftentimes improving operations is the single most important thing to keeping costs low and also to creating innovations within the market. And then ultimately, it improves your project performance, because as your projects become more efficient, as the data is more up to date, and as everyone is able to make a more optimized decision based upon accurate real-time data, then that speeds up the decision-making process, which ultimately leads to accelerated time to first oil. I think I have 2 minutes for questions, if there are any questions. All right. Well, yes, ma'am.
When you're talking about simulating, are you sort of real-time simulating operations, or is it just a case of kind of moving, through a project plan and then showing you moving vessels and stuff?
So what we're able to do right now is simulating marine operations and installation, and then we can do it real time in the sense that McDermott, for example, is using it on their vessels to track the actual installation process.
So you're modeling all of this?
Right, so we're able, and then we also integrate with other project management tools to bring in a more sophisticated project management solution if that's what the client needs. Yes, sir.
You talked about you reviewed it and you see the greater value in new field development finance, the design of 3D models, etc. Have you looked at the existing space in terms of integrating some of these technologies into what's already there? And certainly in this region, the new stuff is there's not as much of it going out there.
Certainly, and what we really said was, what I meant to say is we started with greenfield development, but we're not excluding ourselves from any retrofitting of brownfields or even looking into decommissioning. We have several clients who are actually looking at using this as a solution for field improvements in an existing field environment. It's also very important for clients to have a comprehensive understanding of what exists down hole or in the field for decommissioning. So it's also helpful to create these models of subsea assets for then a plan to remove assets, if that makes sense. Yes, sir.
Right, so this is a data integration platform. So you're taking data from multiple sources, and do you find that you get any sort of barriers to people giving you that data? Like, who owns the data?
Right. So the client owns the data. We host in the cloud, and that can be Amazon's cloud or Microsoft Azure, but we also have clients who host all of this information as well as the platform in their own clouds behind their own secure firewalls. We don't take ownership of the data as far as we don't own that information. The client retains that information. They remain in full authority of that of who controls the access to that data. So it's very secure. Not only is it secure from a cloud perspective, from a technology perspective, it's also secure from as well as client controls. So they retain full access to that. And then with regards to integration, so you're asking a question about engineering systems, et cetera. Through our API, we're able to integrate with a myriad of different engineering solutions. But again, those are all licenses or agreements that the clients have with those systems.
Yeah, so is it like, so your API is like a bridge between different systems?
Yes. Well, I think it's almost like a keyhole. So what it does is it's a key looks a certain way, and you put it into the lock, and it has to fit a certain way to translate to opening that door. So what we do is that API is basically a keyhole that fits a certain way to open up data, so that proper data falls through.
So is that bespoke for each system that you use?
We have some standard APIs. It's all open source, but clients, depending on the level of complication that is involved with the system, some systems are very unique and they're not necessarily just out of the box ready to be integrated. Other systems are very integratable right off the bat. And we have created numerous integrations with clients. Any other questions? Well, thank you for your time. I appreciate it.
Thanks very much, Lauren. Much appreciated.
Thank you.
Mic yourself. And
Oh.
pass it over to Ben. We've got one more before we pause for lunch at 12 o'clock. We're at 1:30. So I'd like to invite David Williams.
Thank you very much.
Thanks very much. And David's going to talk to us a little bit about robotics and the influence on the maintenance and operations sector.
Cheers. Okay, thanks very much. Morning, everyone. I know this is the pre-lunchtime slot, so we'll maybe try and keep it brief if you like. I'm happy to take questions throughout. Obviously, there'll be an opportunity at the end as well, but do feel free to shout out. I don't know how many of you are familiar with Texo. It's a relatively new company based up in West Hill here up in Aberdeen. We're a technology-led but ultimately an integrated engineering services company. So we've, despite being relatively new, as I've said, we've actually been on a round of acquisition, both some interesting companies, but also some very, very high-profile individuals in various different sectors. So we're not just focused on oil and gas. We operate in the nuclear sector as well, in renewables, and I guess the part of the wider group. Whilst it started off as a drone survey and inspection company, we realised quite early on that creating a large company that just does UAV scopes is going to be a very long haul. So that's why we decided to develop a group. So now we've got effectively a full life cycle range now from the basic engineering, fabrication, ongoing maintenance, resourcing, compliance, but equally, and I guess the bit that's relevant for today is the Integrity Plus piece, so effectively the O&M part of the business. The reason I'm standing here today is that my role is focused entirely on our innovation hub, our iHub. So what we didn't want to be was joining the crowd and being like other pre-existing companies providing this kind of service. So the key for us was to be technology-led. So looking at innovation, working closely with partners and various different alliances that we have, but ultimately our goal is to work in kind of joint industry partnership type environments where a client comes to us with a challenge and we will take that challenge away and look to address the technology-led aspects of that. We have a number of strategic partners particularly in academia. So it was working with the technology, both sort of hardware and software. We realised quite early on that it would be arguably quite difficult and in some instances time-consuming to build a team internally. So we now work very, very closely with two universities in particular. Heriot-Watt, which is now becoming the UK's Robotarium, and Professor David Flynn at Heriot-Watt is actually being appointed as our Chief Technology Officer. So he and I work very, very closely in iHub. And that's particularly on, as the name suggests, I guess, the robotics piece, looking at AI as well, but predominantly the robotics piece. That's all very well, but in order to develop the kind of savings that are required and efficiencies that are required, it's not just about how cool the robot looks, it's also about the sensor integration. So we have physical premises at both universities now, but working closely integrating advanced sensor technology onto the robots, whether that's ground-based or aerial, we're agnostic to really. The other benefit of working with the academics is that we're able to tap into some of the PhD schemes. So we've got PhDs dedicated entirely to our projects based out of these universities, as well as some knowledge transfer partnerships. So I would like to think we're well geared up in terms of expertise and the ability, especially through the universities, to tap into very, very specific niche areas of expertise with some of the PhD guys has thus far proved to be really, really valuable. From an iHub perspective, like our kind of, some of these are probably like buzzwords, I suppose, really, but ultimately it's about increasing safety and reducing cost. So if we can keep humans away from dangerous situations, that's always going to be a good thing. But we're looking, well, one of the challenges that we've had with some clients is sometimes resistance to change. It's inevitable. Rope access guys often don't want to adopt the use of UAV technology because it means they're out of a job. But what we're actually doing with our own teams, our inspection guys, is actually upskilling them. So standard rope access guys who are already on an asset are equipped with a range of tools. One of those tools could well be an unmanned aerial vehicle or a drone. And it's up to them to decide whether that's the right tool to use, as opposed to trying to sell a pure drone service to an asset where a drone might not actually be the right answer. Really moving forward though, and this is where the robotics centre really comes in. We're ultimately looking for things that are going to enhance self-certification. So robots need to be, in their broader sense, need to be trusted out in the field, and I guess the same goes for subsea as well. Although we don't currently have any subsea projects within iHub. But we're looking to ultimately make sure we've got as much mission safety as possible. So part of that is going to be in the design of the robots, multiple redundancies, especially the ones that are in the air that can potentially create a large hole in the ground from a kinetic energy perspective. So multiple redundant systems with respect to that. But equally, we need to know that the human in the loop kind of thing is often the weakest link. So we need to make sure that our robotic systems are operating intelligently and able to feed information back to shore or the command centre as to the prognostics of their own systems. So if the battery is starting to fade at a faster rate than predicted based on previous missions, someone needs to know that. And we need to understand whether or not that mission is actually now achievable or whether we need to change the parameters of that particular mission. So that kind of interaction and between humans and the robotic systems is crucial. We are, again, through one of the university partnerships there, we are working on a human-robot interface. A bit like Siri, but works better than Siri. If you know what I mean, it's a natural language interface. So the pilots or the operators of some of these robotic systems actually are going to be, arguably, could be pretty overloaded, especially in an instance where there's potentially issues or the mission isn't going to plan. So the ability to interrogate the system as to how far it is through its mission or what its battery status is, whether its sensors are operating correctly, just with a verbal interchange is possible. A lot of this technology is already out there. The key thing, I guess, is identifying the bits that are going to add value and integrate them together and test them. All with the view of reducing cost, increasing speed of delivery, and keeping people as safe as possible. One of the other things I just want to run through here, I guess, is just a snapshot of some of the projects that we have within iHub. We've been, the good thing, I suppose, from our perspective, we've been inundated with potential innovation opportunities at various different TRL levels. At the moment, I've got over 30 projects in various states of maturity. But just to give you a snapshot of some of the type of things we're working on, it's not all drone related. Some of it is, though. We've integrated a survey grade LiDAR system, which is from the air is giving us between 3 and 5 millimeter accuracies. So the ability to feed into things like digital twins with engineering level scans, both externally and internally, is proving to be very valuable to clients. A lot of work had to go into that. Effectively, it's a large UAV, manned aerial vehicle, with a 300,000 pound scanner hanging off it, which is not your typical drone. So as well as keeping our investors happy that their assets are being kept safe, we also need to keep the regulator happy. And in this instance, it's the UK CAA. So part of our compliance procedures to make sure, especially if something's going to be operating in the air, is that the regulator knows what it is. We have the full operating safety case prepared for it, because their biggest concern is kinetic energy, i.e. how big is the hole in the ground if it actually comes down. It matters less to asset owners or the regulator if it's over water, because it's just going to be gone and make a splash, but obviously it matters to us if that kind of asset's disappearing. So it comes back to a safety point, really, I suppose. And fortunately, we actually have a very good relationship with the aviation regulator and have the most expansive set of permissions for commercial operations in the UK. Other things we're integrating project-wise is 100 megapixel cameras on UAVs and ground crawlers, and SLAM, simultaneous location and mapping. So the ability to take a standard payload on a gimbal and attach it to either a drone or a ground crawler to access areas that people either couldn't or shouldn't be in is again a key bit of development for us. And that project's actually complete now. Other things that we're looking to integrate, and against the sensor type thing, is hyperspectral sensing. I don't know how many of you know about hyperspectral, but essentially, as humans, we see in 3 basic colours. Hyperspectral can see in up to 300 colours. So you can scan an area remotely, and every single, at an elemental level, every single element reflects light differently. And these sensors can actually pick that up. So you can spot any kind of contaminant or chlorates, anything like asbestos or whatever, with those types of sensors. LiDAR I mentioned there, UT, the ultrasonic thickness testing robot we have on display today. I don't know if you're going to have a look at it. It's got a standard NDT sensor on it, but it's been integrated onto a pretty robust piece of UAV equipment. And the latest one coming out of the university as well is this frequency modulated continuous wave radar, which allows us to penetrate through all kinds of substances looking for rebar, gaps, water ingress, etc., etc. That one's not complete yet. Touching on some of the earlier talks as well, resident drones, that's kind of what it's all about, really, from us. Clients wanting us to fly equipment or deliver payloads long distance. Why do you want to do that long distance trip and then try and return? It's just fraught with risk and technological issues. So really, what we're working on at the moment, and 2 of our PhDs at Heriot-Water have this project, is to develop a resident drone system. So something that would actually sit on the asset permanently in a weatherproof housing. It would do all its diagnostic checks before it takes off. We can have it doing pre-planned missions for live stream of data back. Additions to that, it works very well in offshore wind as well from an energy perspective. Having a resident system on a transformer that can survey the entire wind farm as required. Beyond visual line of sight, I know I've just said it's all about resident drones, but some clients do actually want beyond visual line of sight flights. We've got a project just now with a client wanting us to transport equipment and or daughter craft to over 200 kilometres, land and retrieve the system back and return back to shore. So beyond visual line of sight is actually a really big ticket item, but battery technology isn't assisting us with that at the moment. So you're looking at hybrid systems, fixed wing, multi-rotor, petrol engines, generating power for electric motors, etc. So a lot of complex technology, but as I said earlier, most of this stuff actually exists. It's just a question of integrating it in a safe way and then proving to clients that it's a commercial viable solution. It's not all about hardware though. We do have software as well, including data visualization, cloud platforms, so clients can see the data. As it says, it's not about the tech or the sensors, it's about the data and making sure that's actionable for the client. So that was key for us to develop that. And there are a massively overused term, a bit like digital twins, I guess, but AI-enabled machine learning engines that can scan multiple images and identify defects that then undoubtedly need some kind of human overview. But it's all about efficiency and speed and hopefully reducing cost. That's it from me. Any questions?
You mentioned earlier about sort of resistance to change
Yeah.
and trust.
Yeah.
How do you manage the sort of digital trust piece with the technology?
Yeah, so some clients are kind of resistant to change, but at the same time want to embrace their technology. So we generally take clients or potential clients, partners on a journey to explain their technology to them, explain all the redundancies that are in place, give them the comfort that the regulator, where relevant, has actually passed us for approval to operate. But ultimately, it's about taking them on a journey through proof of concept flights, expanding the scopes, proving that we can manage risk. The piece about the sort of human-robot interaction, most people, I guess, don't trust what they can't see. So sitting in a command center and being able to communicate with the system, preferably verbally, but even by text, to see that it's not just the pilot or the operator with his little control screen here. All the mission parameters from a safety perspective are displayed and being tracked real time. And there are a multitude of procedures in place to arrest a situation if something is non-standard.
That's all we have. I can ask, give David a round of applause.
No problem, thank you very much.
You'll all be delighted to hear that that is lunch. If I can ask just quickly before you disappear, I have mentioned it before, but I'm keen, if you haven't done it already, if you could download the app that's on the front of this booklet here, which is a guidebook app, and then scan the QR code, and you'll be able to get a full